Okay, now, so we're at Casa de Miles. Uh, Here it is, Sunday night. I'm about to see you guys tomorrow. Hey, I've got our AP Calculus shirt from last year, the one during a pandemic. I thought that was kind of funny. But anyway, okay, hey, now we're actually going to be looking at some problems that you are guaranteed to see on the AP exam. So this is kind of cool. We're in our second lesson, and already there's something that I promise you, 100% chance will show up on the test. All right, we've got a function at the right here. This is y equals f of x. It's got some weird motions it's got going on here. It's got some points that are defined. And as you know, a function can only be have every x has to have one y, so it couldn't have been in both of those places. So they chose it to be there. This one's just kind of moved up. All right, so let's start answering some of these questions. All right, so the first thing was just it says evaluate the following limits, but she's asked some regular just what are the function values along the way. So f of 2, all right, we just talked about that. F of 2 is not here. That's an open circle. It's actually here. It's -1. Okay. F of -1, of course, they're going to ask that question too. It's not here. That's an open circle. It's all the way up there at 4. So I could say equal on those. That'd be a good idea. Okay. All right. Now, then here we go. The limit as x approaches 4 from the left. All right. So we're approaching 4, but we're approaching it from this direction. All right. So we're approaching from this direction. It's heading to 3. So that equals 3. Okay. The limit as x approaches 2 from the right. So here we are. We're approaching 2. X is 2. But we're coming from the right. We're coming from this direction. So if I was traveling along this road, I would think I was heading to 1. So that's equal to 1. Okay. All right. So all right. So the limit as x approaches 2 from the left. This is 2 from the left. All right, so I'm approaching 2 again, x equals 2, but I'm coming from the left. Well, if I was traveling on this road, I would think I was heading to -1. So that's -1. So you've got to travel from this. The plus or minus is telling you which direction to travel from. All right, so here we go. X approaches -1 from the right. So -1 from the right is heading to 2. Now, I never get to 2, but that's not what it's asking. What are you approaching? What are you heading towards? We're heading towards 2. The function value is 4. That's not what it's asking. If this was a road and this was a road, and I would think I was heading to 2, not knowing that the town was actually moved all the way up here. All right. X approaches -1 from the left is the next one. -1 from the left. I don't know that this even happened if I'm traveling on the road. So if I'm traveling from the left, it's 2 all the way across. So I'm definitely approaching 2. It is 2 because it's constant, but we're still approaching that value as x approaches -1. All right, -4 from the right. Well, that's interesting that they would ask me that because I can't come from the left because there's nothing over here. So I can only approach it from the right. The road, it's a dead end. We'll talk about that more in a little bit. So it's a dead end. So approaching -4 from the right is 2. It actually gets to 2. But that's not what we care about. We're traveling on this road. Man, we're staying at 2, stay at 2, stay at 2, stay at 2. It looks like we're heading towards 2. And though in this case, we actually do arrive at 2. That did not happen on a -1. All right. The actual function value is 4. We never approached that. That was a big old jump. Okay. -4 from the left is a big old does not exist. There is nothing to the left. That's weird to put equals, but does not exist. There's nothing to the left. It's the void. All right, approaching -1. All right, now, so here's the deal. Approaching -1. Since it didn't ask for the left or the right, we have to consider that those two must agree with each other in order for us to have a limit. All right, and so we've seen that before on some other examples. We're going to write this out a little bit more formally here in a moment. But approaching -1, and it doesn't say left or right, we have to do both. All right, from the left, it was heading to 2. From the right, it was heading to 2. So the limit as x approaches -1 of f of x is 2. So, okay, so here's the deal. So since that one was 2, wrong one. Yeah, that one was 2. and this one was 2. That allowed us to answer that the limit itself was 2. All right, what about x approaching 2? Oh my goodness, well, it didn't say which way. Coming from the right was 1. Coming from the left was -1. This is, it does not exist. Does not exist. Okay, cool. All right, what about 5? Approaching 5, okay, from the left, it looks like we're heading to 3. From the right, we're also heading to 3. Those two agree with each other, so it is 3. All right, approaching 0. So x is approaching 0. So, okay, it's a continuous. They didn't even pick up the pencil when they were drawing it, but we'll still argue the same way. From the right is heading to -1. From the left, it was also heading to -1. So the limit is the actual function value of -1. Okay, and what about at 1? Aha, so coming from the right, I was heading to -2. From the left, it was also -2. So you're thinking, what's the big deal on that one? The limit is the function value. Okay, that's fine. But it's all about the traveling. That's what we really care about, the traveling. Okay, if we think of the function as a highway, then at 2, -1 could be considered the end of the road. 2, -1. Oh yeah. Okay, so that road's going, and we just can't get there. So it just picks up somewhere else and goes. Okay, I like that analogy. All right, and then while at -1, 2 is more like a pothole. So at -1, 2 is a pothole. Yeah, a little less than a pothole because that is a point, right? So it'd be like a, I mean, you wouldn't even notice it if you were driving. Now, of course, this is kind of a violent trip we would be taking here, but consider it like this is a map. All right, so if that was a map, then that would be a hole in the road so small you wouldn't even notice it. Okay. All right. How would you describe 2, 1 then, if that's the case? So at 2, 1, I don't know. It's like the beginning of a road, right? So you again, if you're traveling this way, you could still say it was a dead end, right? But if you're beginning here, the road begins and takes off. I think I could consider either of those two. All right, so maybe the beginning or end of the road, right? Because you just can't travel past it. If this is a map, that's the end of the road. So I don't know how you're going to get on the road over here, but you're not going to be traveling along this road to do it. Okay, so I say beginning or the end of the road, depending on which way you're traveling. What about 4, 4, 3? That was kind of a bump if you're thinking of this as not a map, but again, it's a pretty sharp turn. Okay, that's what I want to put. Let's think of this as a map. Oops. Let's think of it as a map, and I'm going to say a very sharp turn. I don't know. You could think of other things, but that's one thing you could say. All right, so can I move it? Yeah, let's make that look a little bit better. All right, so I'm not sure what she said. I'll look at it and see. She's got an answer key, but that's what I'm thinking. A very sharp turn. If I'm thinking of that as a map. Okay, hey, that's it for example 3, and this is a guaranteed. Some of these questions right here, not the function value ones, the limits are guaranteed AP questions. Guaranteed.